Hi, I'm Kathy Welder. I'm a senior lecturer at Dartmouth College, and today I'd like to spend a few minutes talking to you about how I flipped my Organic 2 lecture course using videos and in-class problem solving. By the end of this presentation, you will be able to describe how and why I created lecture videos for my course, and how I run the classroom using a modified peer-led team learning approach. First of all, I decided to record my lectures so that students who feel they need to have lecture content can watch those lectures outside of the classroom. I also felt most comfortable providing the same lectures that I would normally do face-to-face in a recording. And I felt that my department would also support not taking away lecture, but instead using class time to solve problems as a supplement to the lecture material. I elected to make recordings using OneNote on an iPad Pro using an Apple Pencil, mirroring the iPad to my PC using Air Server Connect, and then screen capturing on the PC with Camtasia. So here's an example of one of the screenshots from OneNote. I started out by typing the desired learning outcomes for each short video at the beginning of each lecture. This particular lecture was on the Wittig reaction, and it was the 12th video from chapter 19 of our textbook. I did all I could do to make sure that the videos were not dated, so the 19.12 indicator does not show up in the video. I typed that in to OneNote after the video recording was finished. And I also did not have my face on the screen because I will age, and hopefully the videos will not. Each video was designed to be not more than 10 minutes in length, and after discussing what it was that I wanted students to be able to do after watching the video, I would present a lecture just as I would a chalk talk in the classroom, and at the end I would summarize what was discussed in the video. It turns out the recordings took about half the time as a live lecture, and I believe that's because I had no student interruptions, and I didn't have to slow down and wait for students to catch up as I wrote out my organic chemistry notes. They could simply pause the video. There wasn't any review of what we did last time, and there wasn't any information about the course, such as upcoming due dates that needed to be discussed. Here's another screenshot from OneNote. I was able to import images or PDF files and write on them, so I often provided an image or a PDF to students through our learning management system, and then lectured on top of those notes just like I would in the course. And I know that some people are really into colors when they teach organic chemistry, and this slide simply indicates that it is quite possible to choose many, many colors. The titration curve for cysteine was most definitely the most colorful of all the presentations that I did in any of my recorded lectures. Here's a picture of my classroom. You can see that students were divided into groups of 5 to 6 people, and groups were referred to as teams to encourage collaboration and discourage competition. You'll notice that there's plenty of space for learning assistants to walk around the classroom and assist teams as they work together. In terms of team formation, I looked at making teams as diverse as possible. I considered their grade in the Organic 1 lecture course, making it so that each team had at least 2 people with a B+ or higher in Organic 1, and at least 1 person who was struggling in Organic 1, and the other 2 members were somewhere in the middle. I chose teams of 5 to 6 to avoid teams of 3, where you tend to get a pair and someone that's excluded, or teams of 4, where you tend to break into 2 pairs. I didn't want the teams to be too big because I wanted everyone to have a voice in the discussion. Teams were assigned tables, and those tables would rotate from week to week, so that if you were front and center and didn't like it, or you were in the back corner and felt excluded because you weren't in the middle of things, that was a temporary problem. It would switch the next week. Now, I mentioned that I use a modified peer-led team learning approach. It was modified in that I did the peer-led team learning during the class period, not outside of the class period. And I was present while students worked on problems, whereas in the traditional PLTL model, the instructor is not present. I also provided solutions. So as problems were presented in class, we debriefed them one at a time, and I provided the solutions on the learning management system immediately after class. So in the classroom, I presented one problem at a time. Students worked on those problems until we were ready to discuss them as a class, and then I debriefed them before we moved on. It's important not only to give the correct answer to a problem, but to also discuss why wrong answers are incorrect. We were able to complete 6 to 8 problems in a 1-hour class period, and as I mentioned, the problems and separate solutions were posted on the learning management system immediately after class. One of the challenges of this approach for me was bringing enough problems to stay busy for the entire class period without it seeming as if I thought we were going to do more problems than I actually thought we would. I found that some students thought we were moving too slowly and that people were asking too many questions and we weren't getting to all the problems that I brought. I solved that problem by listing a few problems as skip in class. And that way I would skip them during the class period and go back to them if we had time to solve them, and students understood that I intended not to discuss them if we didn't have time. So my learning assistants fell into one of two categories. I had one teaching science fellow and several learning fellows. The teaching science fellows are hired by Dartmouth, one in chemistry and one in biology, to work full-time for a year with that department. They typically work in the introductory classes. Fortunately, I teach Organic 2 in the summer, and we do not teach Gen Chem in our summer term, so we didn't have any introductory courses, and I got the teaching science fellow. The learning fellows are near peers who have just recently completed the course and are hired to come back to serve as peer mentors. Each learning fellow was assigned to 2 or 3 teams of students, so typically they had not more than 15 students that they were monitoring as we worked problems during class. Here's a picture of my class in action. As you see on the top right, I use an overhead projector to project my iPad. I could write answers to the problems that we were solving and discuss those quite readily. On the left-hand side, you'll see that some students chose to work as teams at the whiteboards that are around the classroom, and you'll see that some teams chose to work at smaller whiteboards at their team tables. Anytime students use whiteboards at team tables, I made sure there were at least 2 markers present so that one person was not dominating the writing and the conversation and not sharing that pen with a classmate. You'll notice that there's stacks of cups at the table. When the green cup was on top, that told me that the students were working and making progress toward solving a problem. If they switched to an orange cup, that means they had a question. It wasn't an emergency or immediate need, but they would like someone to stop by the table when they had a chance so they could ask their question. If a red cup was on top, that meant they were stuck. They could not progress until they were able to have a question answered by either me or one of the teaching assistants. And they put the blue cup on top when they were finished with the problem and they were ready to discuss before moving on. So in summary, I made videos by using OneNote on an iPad, mirrored to my PC, and screen captured with Camtasia. I did problem solving every day in class with near-peer help available. More information about how I run my class can be found in the ACS Symposium series, Active Learning in Organic Chemistry, Implementation and Analysis.